Welcome back to Through Inquisitive Kids. I am so happy to have you here. And in this lesson, we will be learning about the properties of inequalities. And we will be focusing on the learning and applying the properties of inequalities. Throughout the lesson, I want you to think about how these properties are similar and different to those of linear equations. This is lesson 2 of Unit 9. In the last lesson, we had our introduction to inequalities. If you haven't watched that yet, I will be putting its link in the description down below. So please go ahead and look at that first. Now, the properties of inequalities will be essential to simplifying inequalities later on. As we progress into this unit, we'll be spending more time simplifying inequalities and writing them based off of word problems. And in order to really understand the process of simplifying inequalities, you need to understand the properties of inequalities. That's why this lesson is so important for you to really pay your attention on. Learning goals. Understand and master the basic 3 properties of inequalities. Master and skillfully apply the basic properties of inequalities to simplify inequalities. Understand the difference and connection between the basic properties of inequalities and the basic properties of linear equations. All 3 of these things I want you to be thinking of as we go into the lesson. Introduction. We're going to do some review here. Property 1 of linear equations. Adding or subtracting the same number to both sides of an equation doesn't change its meaning. In property 2 of linear equations, multiplying or dividing the same number, divided doesn't equal 0, to both sides of an equation doesn't change its meaning. These are the 2 properties that we learned earlier in our math career about linear equations. So do the properties of linear equations still apply to inequalities? Well, that's what we're going to be discovering in this lesson. Properties of inequalities. This is Exhibit A. This weight here is 100 grams, and the weight on the right is worth 50 grams. And our conclusion from Exhibit A is that 100 is greater than 50. Now here is Exhibit B. Adding 20 grams to both sides of the weight still allows for the left side to be heavier. And our conclusion to describe this scenario would be 100 plus 20 is greater than 50 plus 20, which can be simplified down to 120 is greater than 70. Another way we can think about it is if we start off with 120 is greater than 70, we can subtract 20 from both sides of the inequality in order to get 100 is greater than 50. Think. Use the greater or less than sign to fill in the blanks and conclude the pattern you used. Now I want you to pause the video and fill in the blanks on your own. Well, for the first question, we know that 5 is greater than 3, which means that 5 plus 2 is greater than 3 plus 2. And 5 minus 2 is still greater than 3 minus 2. You can solve this in 2 ways. Either solve and think about it logically. Would 7 be greater than 5? Yes, it would. But you can also think about it more physically. And you added 2 grams to both sides of the scale, the left side would still be heavier. Now here we have negative 1 is less than 3, which means that negative 1 plus 2 is less than 3 plus 2. And negative 1 minus 3 is less than 3 minus 3. Fill in the blank according to the observed pattern. When the same number is added or subtracted to both sides of an inequality, the direction of the inequality sign, does it change or not change? Well, here it never changes. So based off of our observations, it doesn't change. Now let's fill in some more blanks. If 6 is greater than 2, 6 times 5 is blank, then 2 times 5. The answer would be greater than, because if you think about it, if you take 5 of a heavier amount and compare it to 5 of a lighter amount, the heavier amount would still be heavier, which means that 6 times 5 is greater than 2 times 5. Also, you could just simplify and find 30 is greater than 10. But here we're trying to think about it in terms of the properties of inequality. Now, what if we multiply negative 5 to both sides of the inequality? What would happen then? But now you'll find that it's not a greater than sign now, it's a less than sign. Because of the negative sign, everything is turned the opposite way, and since 6 times negative 5 has the greater absolute value, it means that it is smaller. So that is an interesting observation. Let's do some more. Negative 2 is less than 3. If we multiply a positive 6 to both sides, we still have the less than sign. But if we multiply both sides by negative 6, you'll find that it's 12 greater than negative 18. So what can we conclude? When the same positive number is multiplied onto both sides of an inequality, the direction of the inequality sign blank. And when the same negative number is multiplied onto both sides of an inequality, the direction of the inequality sign blank. The two answers is doesn't change and does change. Because as we can see, when we multiply the positive number onto both sides, the direction of the inequality sign does not change. But when it's negative, as shown here, it does change. So here's our conclusion. If we add c to both sides of this scale, which would be a and b, then it would look like this. A plus c is still greater than b plus c. Again, we can get exhibit A from exhibit B by subtracting c from both sides of the inequality. But notice that it's always adding or subtracting or multiplying or dividing the same number or expression onto both sides of the inequality. You can never multiply or divide different numbers onto both sides of an inequality. So property 1 of inequalities. When the same number is added onto both sides of the inequality, the direction of the sign doesn't change. Here's an example. If a is greater than b, then a plus c is still greater than b plus c, and a minus c is greater than b minus c. Property 2 of inequalities. Multiplying the same positive number onto both sides of an inequality doesn't change the direction of the sign. And here it's the same positive number. So if a is greater than b and c is greater than 0, then AC is greater than BC, or A over C is greater than B over C. In property 3 of inequalities, this is something that linear equations do not have. Multiplying the same negative number onto both sides of an inequality does change the direction of the sign. So if A is greater than B and C is less than 0, then AC is less than BC, or A over C is less than B over C. I highly recommend you to jot these 3 properties down, and that would be easy for you when you are solving problems and you can refer back to them easily and quickly. All right, let's move on. Let's do some practice here. If A is greater than B, use the greater than or less than symbol to fill in the blanks. Also include which property you applied to help you solve that problem. I want you to pause the video and answer this on your own. All right, here's the answer key. For the first one, you should have gotten greater than symbol in property 1, greater than symbol property 2, greater than symbol property 2, less than symbol property 3, greater than symbol properties 1 and 2, and greater than symbol property 2. Now I want to go over some things. For example, here it's property 1 because you are subtracting or adding a number onto both sides of the inequality. And for the second one, it's property 2 because it is dividing the same positive number onto both sides. Again, here, it's also property 2 because you have multiplied 0.1, a positive number, onto both sides of the equation. The only property 3 here is negative 4a is less than negative 4b because, remember, the original is a is greater than b. So since you're multiplying a negative number onto both sides of the equation, inequality, it means that the sign of the inequality does have to switch directions. Now this is properties 1 and 2 because there's actually 2 steps to this. You have to first subtract a 3 on both sides, and then you have to divide a 2 on both sides. And it's kind of the same to solving linear equations, except that there is an extra property that you have to be aware of. And here, if m is constant, this is still a greater than symbol, because think about m squared plus 1, this expression, as a number itself. Think about it as a whole. You can even substitute this as, say, x if you wanted to. And this would still be using property 2 of inequalities. Here's another problem. Given that a is negative, fill in the blanks using less than or greater than. Again, pause the video to solve this on your own first. Here's the answer key. Less than, greater than, less than, and greater than. Let's go over them. A plus 2 has to be less than 2. Think about it. A is negative. Okay, so A is negative. And you can think of 2 as 0 plus 2. So then you have the inequality. A plus 2 is less than 0 plus 2. Now using property 1 of inequalities, you can subtract 2 on both sides of the inequality, and then you have A is less than 0, which means that since this can be turned into this problem right here, we know that the sign does not change. It's still the less than symbol. For this one, still think about -1 as 0 minus 1. Here also, any negative number times a positive number will still be negative, which means that for 3, it's less than 0. And here, A is already negative. Multiplying it by -1/4 will make it positive, which means that this is a greater than symbol. If A is less than 0, meaning it's a negative number, and then it is squared, it means that it will become positive, because all squares are positive, which means that this has to be a greater than symbol as well. A cubed would be negative instead, because if you have negative times negative times negative, you'll end up with a negative product. The 7th problem, a minus 1 is less than 0. Think you can add 1 onto both sides of the inequality, giving you a something 0 plus 1. And a is already less than 0, which means this has to be less than. Now, the absolute value of a. Well, a is less than 0, which means that its absolute value is not 0 and has to be greater, which means that the absolute value of a will turn it into a positive number, which means the last one is a greater than symbol. In the last lesson, we concluded that no matter the value of L, a circle will always be larger than the square. L squared over 4 pi is greater than L squared over 16. Do you agree with this conclusion? And can you prove it using the properties of inequalities? Now, this is revisiting a challenge problem we looked at last time in our last lesson. So either you can go back and scroll through the video to review, or you can pause the video and first just try to play around with the numbers on your own first. Here's our solution. According to property 2 of inequalities, we can multiply 16 onto both sides of the inequality. Here it has to say inequality, giving us 4 over pi times L squared is greater than L squared. According to property 2 again, we can divide each side by L squared, giving us 4 over pi is greater than 1. And since the previous expression is an identity, therefore L squared over 4 pi is greater than L squared over 16. Which means that this is how you prove this conclusion using the properties of inequalities. Now we're going to look at simplifying inequalities using the properties. Simplify the following inequalities into the form of x is greater than a or x is less than a. Pause the video and use your knowledge of the properties of inequalities to help you solve. Here's the solution for the first problem. According to property 1, we can add 5 onto both sides of the inequality and get x is greater than -1 plus 5. Simplified, x is greater than 4. And the second one, according to property 3, we can divide -2 from both sides of the inequality and get x is less than -3/2. Remember, since it is property 3 and you're multiplying or dividing a negative number from both sides of the inequality, the direction of the sign must change. Here's 2 more problems. X minus 7 is less than 8 and 3x is less than 2x minus 3. Alright, now here's the answer key. X minus 7 is less than 8. According to property 1, we can add 7 onto both sides of the inequality and get x minus 7 plus 7 is less than 8 plus 7. Therefore, x is less than 15. And for the fourth one, according to property 1, we can subtract 2x from both sides of the inequality and get x is less than -3. Alright, here's your class summary. Today we looked at the properties of inequalities. Property 1 is if a is greater than b, then a plus c is greater than b plus c, or a minus c is greater than b minus c. Here's property 2. If a is greater than b, then c is greater than 0. Property 3. If a is greater than b and c is less than 0, then ac is less than bc, and a divided by c is less than b divided by c. These are all, and then we took these 3 properties and we used it to simplify inequalities. Again, to review. Today we understood and mastered the basic 3 properties of inequalities. We also applied the basic properties of inequalities to simplify inequalities. And finally, we understood the difference and connection between the basic properties of inequalities and the basic properties of linear equations. Thank you so much for watching through Inquisitive Kids, and we'll see you next time.